Hello and welcome to the video notes for lesson 9.2. This is the first video of two. We will cover the portion of lesson 9.2 that focuses on circles only in this video. That will cover examples 1 and 2. So this will be a little bit shorter. So let's go ahead and take a look at our objective. Today we will be developing and applying the formulas for area and circumference of a circle. This is your other objective that we will get to later on in the next video. So let's start off with our warm-up by reviewing a little bit about special right triangles. So you're given information about a special right triangle, and we want to find some of the other lengths. So let's first look at number 1, a 30, 60, 90. They ask you to find the unknown side lengths of a triangle where the hypotenuse is 2. Then number 2, they want you to find the hypotenuse when the leg of a 45, 45, 90 is 4. And number 3, I want you to find the hypotenuse and shorter leg when the longer leg measures 3. So I'll give you a few moments. I've drawn some pictures here for you. Go ahead and try and find those other measurements. If you can't remember them, we'll check our answers together in a moment. Okay, so this is our 30, 60, 90 triangle. It says the hypotenuse is 2. Okay, so if our hypotenuse is 2, remember that's twice as long as the shorter leg. So we would say that is 1. That means the longer leg is that shorter leg times root 3. So the other two measurements are 1 for the shorter leg and root 3 for the longer leg. Number 2. Let's take a look at this triangle. If we have a 45, 45, 90, and we are given that the leg length is 4, that means both of these are 4. Well, the hypotenuse of a 45, 45, 90, remember, is that leg length times square root of 2. And lastly, for our other 30, 60, 90 triangle, get it resized a little bit. For the other 30, 60, 90, they tell you that the longer leg is 3. So if our longer leg is 3, we need to find these other measurements. Now this is a little bit tricky. What that tells me is that 3 equals this shorter leg x times root 3. So if I divide both sides by root 3, that gives me x, but we have to rationalize this by multiplying top and bottom by root 3. X equals 3 root 3 over 3 . So that's just root 3. So if the longer leg is 3, the shorter leg is root 3. And the hypotenuse is twice that, 2 root 3. Alright, that'll come in play a little bit more in the second video, a little bit more than it does today's lesson. So let's go ahead and start with the rest of that lesson. Alright, here we're talking about a circle. We're going to define what a circle is. A circle is the set, that word set there, or sorry, the word locus means set. The word locus means set. So a circle is the locus, or set, of all points in a plane that are a fixed distance from a point. That point we call the center of the circle. So in this circle, we have the center at A. A circle is named by the symbol circle and the letter at its center, the name of that point. So we would call this circle A, as you see in green here. Circle A has a radius we could represent with AB. The diameter CD is the segment going through the center that connects the circle at both sides. So I could also call AC a radius. I could also call AD a radius. Any segment that connects the center to the edge of the circle makes it a radius. When we talk about circles, we talk about the number pi. You'll remember back just a little while ago before spring break, we had pi day. Pi, remember, is the ratio of the circumference to the diameter, or pi equals circumference divided by diameter, which gives us our formula for circumference when you just solve for c. If we multiply both sides by d, we get circumference equals pi times diameter. But diameter is also twice the radius, so it's important to remember that. So we could call the circumference formula 2 pi r. So there's the formulas we have for circumference. And then we also need to remember that our area formula for a circle is pi r squared. So let's take a look at our first examples. In example 1a, you'll notice they give us the diameter 6 inches of circle K. We're to find the area in terms of pi. That means we're not going to put in 3.14 for pi. We're not going to use the pi button on the calculator. We will leave pi written as part of our answer. So we need to find the area. So this is your formula for area, pi r squared. But notice we're given d, diameter. If we're given the diameter, we can find pi by remembering that diameter equals 2 times the radius. So 2 times the radius is 6. That means the radius is 3 inches. So that's what we plug into our formula. So the area of this circle is pi times 3 squared. We only have to take 3 and square it to simplify this. So our area is 9 pi square inches. In example 1b, we are asked to find the radius of circle J if the circumference is 65x plus 14 quantity times pi meters. So if we're finding the circumference, there's one of two formulas we can use. We can either use circumference equals pi times diameter, or we can say circumference equals 2 pi r. If we're looking for the radius, that second option is really the one we should use. So we're going to use this formula. Circumference equals 2 pi r. That means I can replace c with the given value of circumference. So on the left side of this equation, we're now going to write parentheses 65x plus 14, and then don't forget to put pi. Pi is part of that. That value of the circumference is equal to whatever 2 pi r is. So we can go ahead and write 2 pi r on this side. We need to solve this equation for r. Okay, we want to get r all by itself. So I can get rid of everything else on this side. So the thing we need to divide both sides by is the 2 pi. So we're going to divide both sides by 2 pi. Now, you'll notice there's pi. Without distributing that inside, we can leave it right there. The pi here would cancel with that pi. So we're going to go ahead and cancel pi on both sides. And then we really just have the radius is then 65x plus 14 all divided by 2. So we're going to divide each one of those things by 2 to get what our radius is. 65x divided by 2 is 32.5x. And 14 divided by 2 is 7. Let me write that a little more clearly. Okay, so our radius works out to be 32.5x plus 7 meters. All right, why don't you try part C on your own, then we'll check our answers in just a minute. If you need more time, pause the video. All right, let's take a look at what we should get. If you follow the hint, it says first solve for the radius. What we're trying to do is find the circumference when we're given the area. So we're going to use both formulas. We're going to say our area formula here is pi r squared. Then we're eventually going to use the circumference formula. That circumference is 2 pi r. So the first thing we need to do is solve for the radius since we are given the area. So we're going to replace a with 25x squared pi and say that that equals pi r squared. Well, the first thing I would do is divide both sides by pi. You'll notice that cancels them on both sides. Come up here where I've got more room. So we have that 25x squared equals r squared. In order to solve this equation, we need to take the square root of both sides. When we take the square root of both sides, we see that we have the radius on one side equals the square root of 25 is 5, the square root of x squared is x. So that's our radius. Now we can plug that in to find our circumference. Circumference then would equal 2 pi times 5x. Well, we can multiply the 5 and the 2 and get that the circumference is 10x pi feet. Let's take a look at the next example. We've got a pizza making kit that contains 3 circular baking stones. These circles are of different sizes, so they have different diameters, and that's the best way to talk about the sizes of circles here. We have a 24 centimeter diameter, 36 centimeter diameter, and 48 centimeter diameter. The problem asks you to find the area of each stone. So the formula we'll be using is the area formula. Area equals pi r squared. Notice you're given diameters, so we need to convert these to their corresponding radius. 24 diameter would have a radius of 12. 36 diameter has a radius of 18. And a 48 diameter has a radius of 24. So we're going to use those measurements to find these areas. I'm going to do the first one with you. If our diameter is 24, then remember our radius is 12. So our formula says that the area would equal pi times that radius of 12 squared. It says to round these to the nearest tenth, though. So when we do this, we're going to do 12 squared, which is 144, times pi. And we're going to multiply that with our calculator to get an answer. So if we take 144 times pi with our calculator, we'll push the buttons. 144 times pi. On this calculator, I have to hit the second button and then pi. Then hit equals. We get 452.389341. So we're told to round to the nearest tenth. So we're going to round our answer to approximate area of 452.4 square centimeters. That's the smallest baking stone area. I want you guys to now take some time and solve each of these other stones for an area in square centimeters. When you are ready, continue watching the video. If you need more time, just pause, but you should see the answers in just a moment. Alright, we should get the following answers. When our diameter is 36, we should get an area of about 1017.9 square centimeters. When our diameter is 48, we should get an area of about 1809.6 square centimeters. Alright, that wraps up this video. Went a little bit longer than 10 minutes, but that's okay. We will continue with a worksheet over these kinds of problems, just circles, when you get to class on Monday. Hope this has been a good review of area and circumference of circles.